Alright, you write exercise 2. You are working with me now. Okay. Number 1C says, prove that 2 to the power of x minus 1 plus 4 to the power of x plus 1 is equal to 2 to the power of 2x. Now, we spoke about equations and expressions. Now, visually, if you look at this thing, it looks like an equation. Do you agree with me? But this is not an equation. This is the left side, and they want you to simplify it to look like the right-hand side. That's what prove that means. Okay, so that's why I told you it's very important to understand the expression and the equation part. So we're not going to solve the value of x. We're not going to move underneath the equal to sign. We are only working with one side. And whenever you are doing something like that, you're not allowed to carry this side with you. You just write it like that, and then you go on with the one side. So we have to simplify this side. Now the first problem I see there is that there is a base that's not a prime number. Do you all see it? And that's 4. So we're going to start by taking it to a prime number base. Please take note how I write that now, because it's 4 to the power of x times 4 to the power of 1. That's what that means. So therefore, if I write 2 to the power of 2, that 2 has to multiply with the x and with the 1. Now, I prefer, with certain sums, not all of them, to give each exponent its own base. Okay, it makes it easier for me to see and not to drop something. But it's not compulsory, so it's your choice. First 2 steps. I want to know, are there any questions? You guys need to talk to me. You need to tell me when you aren't sure. Yeah. Oh, I forgot the 9 over 2. Sorry? Thank you. Okay. Okay. Doesn't change what I did there, ne? Still the same. Now, do you remember I said to you that we have a problem when we have multiple terms, more than one term? Then we cannot apply our exponent laws. So it doesn't help us at all knowing the exponent laws when I've got more than one term. When I've got more than one term, I want to get it to be one term. The way you do that is with different types of factorization. The first one, the most common one, is to take out something in common. You know how to do that, ne? Okay. The second way is a quadratic trinomial. That's factorizing the haki-haki. The third way is the difference of two squares. That's when you've got a term that's a perfect square minus a term that's a perfect square. Now when I look at this thing, it is not the difference of two squares because there's a plus. That already gives it away. It's not a quadratic trinomial, and you cannot take this one to the left hand side and say it's a quadratic trinomial because this is not an equation. But when I look at it, I see that I can take out something in common. Both terms have a 2 to the power of 2x. And then what remains here is 2 to the power of negative 1 plus 2 to the power of 2. Everyone clear? If you don't write that base there, sometimes you guys just forget about the negative 1. So that is just the reason for me writing the base of 2 with every exponent. What does 2 to the power of negative 1 mean? A half. So this is a half plus 4. A half plus 4. That gives me 4 and a half. Now this is simplified as far as I would simplify it if I did not have the right hand side. But the right hand side is telling me that I must do something else. I must get this fraction to be an improper fraction. So I'm going to say 4 times 2 is 8 plus 1 is, that's 9 over 2. And then I say left side equal to right side. And then you're done. This is not your typical exam question. That is why I'm only going to do one of the question 1 sums. But, you know, we don't know who's setting the paper, so it can be in there. There's nothing different to the ones that we're going to do. The only thing is that you understand that this is not an equation. Don't move it around. When they say prove that, it's left side equal to right hand side. Yes, I'm listening. A 2. Okay, number 2a. I'm going to do the left column with you, the first column, and then you guys are going to do the second and the third, because it's all the same. Once you get the method, you will be able to do it yourself. This first one is kind of like the grade 10 sums that you were doing, that we did for homework, the revision activity. There is not a lot that's new to this one. Please take note, the top only has one term, the bottom only has one term, which means that we can apply our exponent laws. But before we can apply our exponent laws, we need to find bases that are the same. Now, there's a 10, a 25, a 5, and a 50. Can you see that the bases are not the same? But they are not in their prime number format. So that means there is an opportunity for me to make them the same, if they have things in common with their prime factors. So if I look at 10, what can I do with 10 to break it up? 2 times 5, or 5 times 2. And then it's to the power of x. 25? And this is the way I write it then, like a distributive law. You understand? 5 is just 5, ne? Here at the bottom. And 50?
2 times 5 to the power 2.
2 times 5 to the power of 2. And I close it and I put the x or the exponent on the outside. And it's fine. Maybe all of you didn't immediately see that it's 2 times 5. Oh, yeah, 2 times 5 to the power of 2. Maybe some of you were thinking 2 or 10 times 5. Ne? I'm sure there were some of you thinking 10 times 5. But then you notice, oh, but 10 can still be broken up into 5 times 2. And then you will notice it's 5 times 5 times 2. Or 5 to the power of 2 times 2. So it doesn't matter how you get there. Just get there. Right, now we have to simplify this so that I have bases with exponents. With this first one, when the exponent is on the outside of the bracket, it needs to multiply with all the exponents on the inside of the bracket. Therefore, I have 5 to the power of x times 2 to the power of x times 5 to the power of 2x plus 2. So that 2 multiplied with x and it multiplied with the 1. Now you are welcome to already give that a 5 if you want to do that. Over 5 to the power of x times 2 to the power of x minus 1 times 5 to the power of 2x minus 2. Are you all happy with everything I did up to there? No questions? Now the following thing I'm going to do, you look at me. You can only do when it's one term at the top and one term at the bottom. You don't ever do this if there's more than one term either at the top or at the bottom. But if everything is one term, you can start with one of the bases. Let's say 5. Now I look at the ones that are on the same level with it. These are multiplication sums, ne? What's the rule when we multiply? Add. So I'm going to say x plus 2x plus 2. And now the other ones are at the bottom. Division is minus. So it's minus x minus, and then please remember, put it in a bracket. Because you have to minus the 2x and you have to minus the negative 2, which means it becomes a plus. And then you go to the base of 2, it's 2 to the power of x. There's not another 2 at the top, so I just leave it. And then to the bottom, minus bracket x minus 1. There's not another base of 2. You are also welcome at this stage to cancel out if you like. Sometimes I see that learners start to confuse themselves when they start cancelling out here, because then they miss the minus, negative, and those things. But it's your prerogative, you can do it whichever method you prefer. Alright, now the thing with these exponent sums is you are always going to have Gogga exponents. A Gogga exponent is one that has an x in it. Now we expect the Goggas to disappear. If the Goggas don't disappear, you probably made a mistake. Except if there's a single answer like 5 to the power of x. That's one thing, but we expect it to become small. Now look at this. What is x plus 2x? 3x minus x. 2x minus 2x. Nothing. The Gogga is gone. You see. Then we go to the normal numbers. 2 minus minus 2. So that's 2 plus 2 is. So I've got 5 to the power of 4. Then that thing is gone. Then I go to 2. What is 2 minus x minus x? It's gone. Minus minus 1. And now at this stage, when all the Goggas are gone, and you've written all the exponents positive, you will see they won't just remain this simple, but you will know when you get there. Now you are allowed to cheat with a calculator. Okay. You don't have to, but you can cheat. Especially when they become complex. Don't waste time with fraction rules now, because one, you'll make a mistake, two, you'll waste 5 minutes. And maths is about time. So 5 to the power of 4 is 1250. It's 625, already giving the answer. 625 times 2, which gives me 1250. And that's your final answer. Any questions? Next one I'm going to do is number D. 2D. Can I page? Everyone happy? calculator. Nog nie nou nie. When you start doing the activities, you can borrow it. Okay. See ya? 8. Okay, wait, before you tell me, you break up 8 for me. How many terms? One term, one term. That means we're going to get it into prime numbers, and then we're going to take the prime numbers that are the same and do the plus and minus thing. That's the method for one term. Okay, see ya? 8. 2 to the power of 3. And then, no wait, just wait, n. Right, 6, review it. 2 times 3, n minus 3. Right, 9. 3 to the power of 2, does I? Okay, 16. 4 is not prime. 2 to the power of 4. Okay, and then the 3 is fine. Do you see now you have bases that are the same, no? There's a 2, there's another 2, there's another 2, and then the others are 3. 3, 3, 3. That's what I want, no? Now I just want to simplify it so the exponents look better. So I've got 2 to the power of 3n times 2 to the power of n minus 3 times 3 to the power of n minus 3 times 3 to the power of 2 minus 2n over 2 to the power of 4n minus 4, 3 to the power of negative n. Grade 11s, do you all understand what I did up to there? Is that something you would be able to do? So all I did was, step 1, most important, identify which type of sum this is. If you don't take the time to go and look at that, you're going to make mistakes later on. Because you see how complicated this thing is starting to look. Now you can imagine if I have plus to indicate terms in there as well. You can mess it like that. So you must know what you're doing before you're starting to do it with these sums. Now I take my basis, it's 2 to the power of 3n. It's next to it, so I can add it, n minus 3. That minus doesn't change. You just write it as it is there. Now I go to the bottom, minus bracket 4n minus 4. Then base 3. 3 to the power of n minus 3 plus 2 minus 2n minus bracket minus n. It's fine. I'm just showing the steps. Remember, I told the Afrikaans class also, I will do it very thoroughly. But all the steps is not needed. But rather start it thoroughly until you are an expert. Then you can start leaving things out. I expect the gogas to disappear. 3n plus n is? 4n minus n? Weg. Minus 3 minus negative 4. So it's minus 3 plus 4. So it's just a 2, ne? N minus 2n. That gives me minus n. Plus n. Gone. Minus 3 plus 2. Huh? Negative 1. Now I just have to write it correctly. 3 to the power of negative 1, what does it mean? You just move it to the bottom. If the they don't disappear, there will only be like one single one. The answer will be like 3 to the power of n. But I want to answer you and say yes, the hojas will always disappear. But as I said, we don't know setting papers. Maybe they try to catch you, but there won't be multiple hojas in the question or in the answer.
Now, I have a question that I want to explain. So in the normal sum, when you're doing multiplication, you're using x as the symbol. For these, you're using a dot as the symbol for multiplication.
Yes, there are different things that mean multiplication.
Is that because in this, the multiplication doesn't separate terms?
Yes.
Okay, thank you.
But it can be indicated with a multiplication sign. If you want to put in the multiply, you are more than welcome. A multiplication sign, a point, and basically nothing. If you put nothing in between, that also indicates multiplication, but not like between two numbers.
The reason we're using a dot here instead of the normal x is to show that we're not separating the terms.
It's not really to show something, it's just the way I write it. I guess you can write it with the multiplication. It doesn't do anything. Like there, I just left it out. Sometimes I write the multiplication. You will see when when we have multiple terms where there's a plus and a minus in between, especially when we get to trigonometry. Then I will say, rather write in the multiplication so that you see this is multiplied.
Okay, so
But this is just like a shortcut to work quicker instead of writing the sum.
and the plus and the minus is what separates the two, not the multiplication.
Yes. Okay, G. This is now the type of question that we will get in an exam and in a test. They only give you one exponent sum in an exam. And now in grade 10 you did them with only one term. Now in grade 11 we're doing it with where we have two terms. So obviously we rather expect them to give us something like this. But we are prepared for this when there's just a single term. But we expect them to give us this. The method is more or less the same. If the bases are not in prime number, we want to get it to prime number base. Just as we did when it's one term. But we cannot do that step or start cancelling out when we've got more than one term. Even if it's just at the numerator or just at the denominator, you cannot cancel out. So as with number 1, let's see, I'll say that now. Was it you that said it? What did we do at number 1? I thought I heard you say. What did we do at number 1 when it was more than one term? We factorized. So that's what we're going to do here. How do we factorize? Take something out in common, the difference of two squares, quadratic trinomial. We don't do grouping. Okay, you can bury that. Now if I look at this, all of them are prime. I'm happy with that. At the top, which factorization can I apply there at the numerator? What am I going to do with 2 to the power of x? Take it out in common. What remains with this first term? And with the second term? Now at the bottom, what can I do? What remains at the first term? A 1 plus 2 to the power of 2. Why must it be a 1? Because that one is holding the place for 2 to the power of x when you multiply it back in. If you don't have it there anymore, that term will be gone. If you write a 2 there or something, it will become a bigger base or bigger exponent. So you can check it. 2 to the power of x times 1 will be 2 to the power of x. 2 to the power of x times 2 to the power of 2 will be 2 to the power of x plus 2. So it checks out. Now look at that. Do you see what can cancel here? What is that thing? What is cancelling? The hoja, the hoja, the hoja. It's gonna disappear. There we go. It's gone. What am I left with? 3 minus a half over 1 plus 4. And then you take out your calculator and you type it on your calculator and you get an answer of a half. You are more than welcome to show me how good you are with fractions and do it without the calculator. But don't do it in the exams. Okay? You are wasting time. I don't need to see anything to give you a mark here. So you can somewhere right there, cheat with calculator. Now don't write it on the paper, just write it now. So you know, because there's going to be many places where we can cheat on it with a calculator. But I mustn't notice that you use the calculator. So for example, if you write 0.5 here, that is the calculator answer. I know you know a half is 0.5, but 0.5 is a calculator answer. You write 1 over 2. Do you understand that? Should I do another one with you that has multiple terms? Let's try another one. F. Stop complaining, my magtig. You know what I'm going to do? I'm going to give you this one to do, but I'm going to do it with you before you go on. Okay, so you... F. Before you start it, I want to show you something. The numerator has 2 terms. So there you're going to have to factorize. The denominator only has 1 term. Don't take out something in common there. It's one thing. You don't take it out. Just get it into prime number. And then you look. Maybe the thing that you take out there will also repeat at the bottom and then you can cancel. We're looking to get rid of the hoja. Go. I'll give my steps in 1 minute. Then you can check if you're on the right path. Try it, everyone. Even if you're doing it wrong. While we're speaking about calculators, I told you guys about getting a calcium. You see, so I have another calculator that's a sharp, but I can't work with that one when we work with the functions of the calculator. It won't even help if I lend you this one, because when we get, you're going to have to get a new one. Casio. Okay. Wash your parents' cars or something, so you get some moolah. Huh? Yeah. Ah, sorry. This is 2x. Sorry, man. You want some Tipix? That was for you, Sia. Can I do my first step? You are welcome to give each exponent its own base, no? Not necessary, but you can. my next step, I took out a 3 to the power of 2x at the top. Then I have 1 plus 3 in brackets. Remember the 1, it's a placeholder. At the bottom, I just simplified the exponents. There's nothing to take out. Can I cancel? Ho, 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 ho. I still see another ho, ho. Do you see the other ho, ho? 2 to the power of x, but there's another 2 to the power of negative x. I'm not going to take it to the top. I'm just going to simplify this bottom, this denominator, like I did when it was one term. Right? X minus x, gone. So I've got a 4 at the top, I've got a 2 at the bottom, and my answer is 2. But do you see it gets tricky when the 1 has got more than one term and the 1 has only one term? So you need to be able to jump from this method to this method. And this is what they do in the exams. One has got more than one term, the other has only one term. Okay, that is what I'm going to do with you at number 2. Now I'm going to do 2 sums at number 3, then you're going to do the rest of number 2 and the rest of number 3 for homework. It's not a lot. At number 2 it's 1, 2, 3, 4, 5 sums, and at number 3 it's 2 sums. Number 2 is the important one. I want to start with the numerator. Do you see the top and the bottom has got 2 terms? So I know I need to look for some sort of factorization. How can I factorize at the numerator? What can I do? You always start in that order. Can I take out something in common? Yes or no? Is it a trinomial? Yes or no? Is it the difference of 2 squares? Yes or no? So we start at the first one. Can I take out something in common? I heard a no. I can take out something in common because this one has got a 2. That thing consists, let me just show it for anyone who might be confused there. 2 to the power of 2x means 2 to the power of x plus x. But it looks like this. 2 to the power of x times 2 to the power of x minus 2 to the power of x. So do you see they both of the terms has got 2 to the power of x in it. That's why I can take it out in common. So what's going to remain here is 2 to the power of x minus 1. If I look at the denominator, is there something in that they have in common? No. Are there 3 terms for a quadratic trinomial? No. Is it a difference, almost, of 2 squares? That one's a perfect square, but that one is not a perfect square. So there's no factorization that I can do. Look here. Whole term out. So see, do you see now I have a ho in my answer, but it's simplified. 2 to the power of x. Julle gaan sing. Okay. I'm going to keep you. I'm not going to let you go sing. Listen to me. There was a question in the Afrikaans class. The question said that I said that you cannot cancel out when there's more than one term. But now I'm cancelling out. The reason I'm cancelling out is because I'm cancelling out the whole thing. I cannot cancel out one of the 2 terms, but I can cancel out the whole thing. Does that make sense? Okay. D. And I'm doing D with you because this one has got a little bit of a trick in it. But they don't really ask these type of questions in the exam. It's question 2. Those are the ones that you will see in every old question paper that you work out. Okay, tell me how to change 16. 2 to the power of 4. Tell me how to change 4. X. At the bottom I have 2 to the power of x, and I can change 4 as well, ne? 2 to the power of 2. Now before I ask if I can take out something in common, this thing means 2 times 2 times 2 times 2. This one means 2 to the power of x times 2 to the power of x. Does it have something in common?
No.
This is 2 to the power of 1, 2 to the power of 1, 2 to the power of 1, 2 to the power of 1. This is 2 to the power of x, 2 to the power of x. Can I separate the x and the exponent and the base? That is the base. That's the whole thing. So can I take out the 2 to the power of 2 there? No. Because that one actually has nothing to do with a 2. It means there are 2 x's. Do you understand? So I cannot take out something in common. Is it a quadratic trinomial? No, it's not 3 terms. Is it the difference of 2 squares? Is this a perfect square? Yes. If I take the square root of 2 to the power of 4, it will be 2 to the power of 2. Is this a perfect square? Yes. If that number is even, it's perfect. Okay. So when I factorize the difference of 2 squares, I make 2 brackets. I say this one's square root, 2 to the power of 2, 2 to the power of 2. I say that one's square root, 2 to the power of x, 2 to the power of x, and then the 2 brackets signs will differ. Do you understand what I did there? Can I take out something in common here? No. Is it a quadratic trinomial? Is it the difference of 2 squares? No. That one is a perfect square, but that one's not perfect square because that is a uneven number. So I can't do anything there. This is 2. Now looking at this, please tell me, can I do what I did at the previous one and cancel this one with this one? Why not? This one is positive 2 to the power of 2, negative 2 to the power of x. This one is positive 2 to the power of x, negative 2 to the power of 2. But you know there's a solution, eh? What do? I just take out a negative. Now you can take out the negative there, then you just put a negative in front and one of the brackets swap around, the terms inside of the bracket, not all of them, just this one. Or you can do it at the bottom. I would prefer taking at the bottom because it's less complicated there. I just take out the negative and they swap around. And it will look like this. 2 to the power of 2 plus 2 to the power of x, 2 to the power of 2 minus 2 to the power of x, over negative bracket 2 to the power of 2 minus 2 to the power of x. And then whole thing. Now I just move the negative up. My answer is negative 2 to the power of 2 plus 2 to the power of x, and we can simplify it further. No? We can just multiply that negative in to get rid of the brackets. It will be negative 4 minus 2 to the power of x. So you see it's got a lot of tricks. It's the same method, but it's got some tricks in it. Those of you who want to go and sing can go and sing. The rest of you that don't want to go and sing, you can start with that activity now. I'm going to remain in class and start giving the answers. I'm also going to finish the memo and take a picture of it and send it on the math group. Is there anyone that's not on the math group? Who is admin? Please get them on the group. Can I send the memo on the group and then you mark it for me already for tomorrow? Look at me. Look at me. If you don't do it and you just copy from the memo, dan is jy you are cheating yourself. Okay? Rather leave it out than go and copy from the memo. These are exam questions. 12 o'clock tonight. If I've sent it and you haven't done it yet, just don't open it. Just finish it before you take a look at it. I know you. They must delete you from the group. I just want to stop the video. Just give me a second.